What is this, Lady Ada?
We're on air, we're live, we're here at the Adafruit factory. It's me, Lady Ada, with Mr. Lady Ada, and now is our time to watch you, the makers of the world, come together and show off your projects, whether it be 3D printing or accessible technology or like laser cutting or electronics or like basket weaving, cosplay, whatever it is that you're hacking on, whether it's done or not, we'd like to check it out.
Right.
So from now until about 7:55, we're going to be here. We're going to call on you. The order we see you in the boxes, show off your project for 2 to 3 minutes, and then mute your mic when you're done. And that way we'll get to everybody and we'll get to see what people are up to.
And if you're showing your project, you get a Seen on the Show and Tell sticker.
Oh, yeah.
So first up, Tony D, what you got going on this week?
Hey, yeah. So over the weekend, I was at the Emerald City Comic-Con in Seattle, Washington. It's where I got this sweet shirt at. And I had a little cosplay, so I dressed up as Tony Stark, the Iron Man kind of character, who has the famous arc reactor on his chest. And I've got these 2 arc reactors here. Now, one of these things is not like the other. You might not even really be able to tell the difference, but this one on my right is actually powered by CircuitPython. And so it's Python code that's driving all the animations. And they're the exact same animations as on my left. This is just classic Circuit Playground with Arduino code that's running these animations. So really cool test that basically I did. I implemented the same animations, same functionality. You can change the colors and the animations by pressing the buttons and things on here. And it works great. It's the same in both languages. It's a little bit slower on the CircuitPython version, but it is interesting. It's more accurate. The animations, like the colors fade a little more kind of smoothly, or the math is a little more correct because it's using floating point, whereas in Arduino it's not. So neat things, but check out, I did a video on the YouTube channel where I showed the implementation of both the Arduino code and the CircuitPython code. So really good example if you're an Arduino person that's kind of slightly familiar with Python and wondering how to make that jump into the Python world. Here's a really good non-trivial example of how to actually do something in Python that's not just hello world or blink a light. This is actually, do some animations and color stuff and see that, you can do the same stuff in Python that you can in Arduino. And I go through some interesting performance issues and kind of trade-offs in that video too. So
sweet.
It's amazing that there's a difference too, and then people who are familiar with one can compare and figure out which one's easier and what.
Right, you can look at the code and see like something in Python, like making a list of things is a lot easier than in the C and C++ world for it. So it's kind of good example of that.
Very cool. All right, well, thanks for going out there and showing off all sorts of electronics. That's one of the places that we want to take CircuitPython specifically to make it super easy for anyone to make their costumes light up and make some noise.
Exactly, yeah. And if you check the blog, I think I had a little post with like 30 or 40 pictures. I was looking for all of the electric cosplays, people that put lights on things. And so there's actually a bunch of opportunities. So if you're doing cosplay, add some lights. You'll stand out. You'll be unique, get more attention.
Easier than you think. It will be. All right, thanks so much.
Okay, thank you, Tony.
All right. Now, Pedro, what you got printing this week?
Hey.
Hey guys, how's everybody doing?
All good.
I just wanted to share with you guys an update from earlier today. So I've been doing a couple live streams. I started it yesterday, I believe. All the days are blending in together. But this is a project that was inspired by Bill Binko, who is in the chat over there. He's the head of atmakers.org. So the goal for this project was to make a sort of a multi-purpose enclosure for the feather line of boards. So I actually have all the feathers, not all of them, but most of them. So here's kind of what I came up with a lot of help from Bill and the community. So I've been doing these live streams, and it's really cool because it's sort of a collaborative effort where everybody's kind of throwing in ideas, and that could be kind of, ideas clash and stuff. But it came out, it's coming out pretty well. So this is sort of the enclosure that I came up with, and one of the cool ideas that Bill had was to kind of figure out a great way to mount, since all the boards have kind of different sizes, they're slightly different. One thing we could do is to make these sort of slots. So these standoffs here and these holes have sort of a slot, so you can kind of have this variable mounting hole for these things. So that's pretty nice. And these are those nylon screws, the 2.5 M screws that we have. And the idea is that we'll have different toppers and different bottom pieces that will connect different batteries. So for example, this was kind of why the enclosure is a little bit bigger. It's because you can kind of house a battery. It won't go on top of it because we'll be able to put feather wings and stuff. So the idea is to have something that's kind of down here. So what I worked on today on today's live stream was sort of modeling the OLED feather wing component. So I put that together, and hopefully if we can get this in right, we'll see if everything works out okay. So I just snapped that on there, and then I have different toppers. So I kind of have one that kind of closes everything, and then this one kind of has a couple of openings for the buttons and the OLED display itself. And I'll you know, I still have to do a couple of things, like to have like a hole here for the JST connector from the battery. So hopefully that works just fine. So you know, the idea is that we'll have different scenarios where folks can either have something that's kind of powered externally, or we'll have like I was saying, that bottom compartment that will kind of clip into this bottom, so you can house the LiPo battery. Yeah. So it's although it looks like a really simple project, there's a lot that you have to kind of think about, because you're trying to make this for all sorts of different scenarios. So that's sort of where I'm at with it.
Looks good.
So check out the live streams. I'll probably do another one tomorrow. So I'm trying to do one a day. I think we'll kind of be we're gonna get this kind of out as quick as we can.
Yeah, those are, when you do a live stream too, you don't have to edit it, so it's kind of nice. You can show the work in progress. And
yeah, that is always a good thing. But then I always forget to unmute my mic, so I'm talking for 5 minutes and I'm not saying anything.
That's all right.
So
yeah, you have to have the chat room in your head. So it's, woo. All right. So thank you so much.
Thanks, folks. That's good.
JP, what you got going on?
Yeah, JP.
Hey there. So I've got, I've been showing little bits of this online, and people have been asking about my clock segments. So I'm working on the guide, should be out by the end of the week, and video end of the week or beginning next week. This is going into a Ninja Warrior gym for a competition this weekend as a 5-panel. But let me plug it in. So essentially what this is LCD style 7-segment display made from NeoPixel strips. And so I have cut 7 strips from 8 pixels each from the 60 per meter strips that we have, wired them together. And so one panel is one pin on the Arduino. And so I'm making my life easy that way. So each panel is a different pin on the Arduino. And then what I've done is I've created this CAD drawing that'll be available in the guide that you can use to either print and trace and cut, or if you can use a laser cutter, that's the best way, acrylic in my case. And so what I'm doing is I'm getting a few layers of acrylic that space the LEDs away from these top sections. Let me see if I can pull one of these out. They're taped in the back. Oh, let me rip this whole thing apart for you, in fact. And the key thing here is actually getting yourself some distance from your LEDs to the diffusion. Otherwise, you'll see all of the distinct dots. But here, if I peel off, this one's just got some gaffer's tape on it. This is my prototype one. So what you'll see is I've got a cutout layer of acrylic, and there are the actual NeoPixels, which are crazy bright. But on this bottom layer, I just have acrylic, and then I have extra spacing here that gives me about a ½ an inch or a little more, maybe more like 3/4 of an inch distance, which is what gives us that really nice diffusion effect.
It's not that much, but just as long as it doesn't start touching.
Exactly. Yeah. If it's too close, it's very obviously 8 little dots that are behind some sort of milky white plastic. But as soon as it gets far enough away, you're good. And if you aren't careful, you'll see them bleed into each other. So I actually have the segments carved out all the way through that acrylic. So it's not just that it's far away, because you'd see all the soft light on the edges of ones you weren't lighting, but instead it's essentially a little tunnel, a little light tunnel that runs to kind of separate that lighting effect per segment.
Mm-hmm. All right, right on. Thank you so much, JP.
You're welcome.
All right, I was going to say, no, Pedro and JP, if you could pop out, we have a full room. Chris Young's trying to get in, so watch from the YouTubes. All right, we're going to go to, let's see, Anirudh? Anirudh?
I think he's busy talking to someone.
Hello. Unmute your mic and show us your project. Oh, we can't hear you, but maybe turn on.
Okay.
We can hear you now. All right, show your project.
I have this. Initially, I was gonna attach it to this glove, but I wasn't really able to. I'm actually gonna be doing it sometime. I'm not sure when, but Okay. Actually, I might do it right now, but I have this like button here, and it's supposed to. I wasn't really supposed to. Well, power this light bulb, and I also have a motor with me. The bulb is. And then when you, it's not working. I don't know why. Oh, it's working.
Okay,
Oh, there
so
you
when you
go.
press the button, it lights up.
Yeah.
That's awesome.
I'm actually gonna attach it to this glove, and there's also a motor here. It can also power that. But for some reason, when I attach it to the button, it just goes. Like the button won't work. Like
Try
it's like
connecting to the
it's like it's
opposite
ignoring
corners.
the button.
Yeah, try connecting to the opposite corners of the button.
Actually, I might try using the button right now. Hold on.
Okay. Well, we're gonna keep doing show and tell. So why don't you keep hacking away at that?
We'll come back to you.
Yeah, we can come back to it, but also no matter what, email support@adafruit.com and we'll send you out as seen on the show and tell sticker.
Okay. Can you come back to me for the motor part?
Yeah.
If we have time, we absolutely will. Otherwise, come back next week.
We're gonna go with some other people, so get it ready.
We got a full house tonight. All right.
Thank you.
I saw Chris Young. He was in for a second, and then he's out. So, Bill, do you want to talk about Chris's project a little bit while he tries to get back in?
Sure, and this is 100% his. So, hi everyone. Can you hear me? Okay.
Yeah,
you
you sound great.
All right. So I will tell you the background, and then when Chris comes on, he can talk about the actual technical work that he did. Okay. So this all started a few weeks ago. I got an invite from UF to go up and teach some people how to solder and do AT stuff. And they wanted us to do some more of our My Pal Violet adaptations. And they're pretty simple. They're basically eight soldering points and you're done. It takes a while, but it's not that complicated. And so I said to the community at AT Makers, what else could we do? What are the things that you guys would really like to see? And the number one, and I can't do this one in a couple weeks' time, is all these folks who are using switches want a flying drone with a camera that their kids can control. And I was thinking about the one that Lady Ada and Colin used that seemed to be really steady and stable. That might be a good starting point for that.
Yeah.
That's a long-term project. In the meantime, like the number two was this guy, okay? They wanted to have the BB-8 to be able to be controlled by switch control. So Chris did that. I gave him information on I used the Saleh logic analyzer and gave him a screenshot. He bought his own, he hooked it up, and he basically decoded it. And what I was going to show is I actually have one working. So rather than just take the remote here and see if I can get this thing to wake up. That would be bad, wouldn't it? After all this work. All right, we got it. 1 second.
Sleepy droid.
Yeah. All right. So rather than just take this and adapt the buttons, we actually took an Arduino or took a feather, BLE feather. And this is not my best work, but basically it's a good prototype board. It's got an infrared, it's got 3 buttons and a little 5-way switch. It's also got a jack so that they can control it with an AT switch. Okay? So, real quick, let's switch over to their camera. All right.
Camera work.
Yeah, I know. The camera work sucks, right?
No, this is
really
great.
good.
All right.
I like that you have the little bumpers there. Good demo.
Yeah, so it kept going on the floor, so I had to do something. So this is the actual one it comes with, and it's got a crazy strong IR in it. And this is the one that works using his control. And what's neat is if a kid only has 2 switches he can control, he can go forward and right. If he only has 1 switch, like one of these AT switches, he actually can tap it to turn the head and then hold it down and it'll go. So we have the ability to add a little bit of logic and therefore adapt this to meet the needs of a particular child.
Oh, that's fantastic.
I love the one button, like changing the function.
Yeah, it's really hard to think sometimes about how you can get one button to control whatever it is they need. It usually has to do with delays in time, but this could not have been done without Chris. So it really bums me that he couldn't get in and show how he did it, because my job really here tonight was just to demo this.
Oh, that's fine. We'll get Chris on the show next week. He's here often. And,
Yeah.
More content for us.
This
2 weeks
is
worth.
great. And
Yeah. Oh, by the way, I wanted to thank your guys, Noah and Pedro. All the stuff they did on that box is awesome, and that like every project needs a feather, a battery, and a buzzer.
yeah.
And they took that and they're running with it. I think it's awesome.
All right. Well, of course, we'll send you out a show and tell sticker. And thanks again for all your work with the atmakers.org.
Okay, sweet.
All right. So next up, we're going to go to Matthew. Hey, Matthew, how's it going? Unmute your mic and show us your project.
Hi there. So my project is a binary clock, and if I move out of the way, you can actually see it behind me.
I see a cat. It's really cute looking.
Yeah, it looks like
So it's made out of wood. It's about 4 feet wide, and it uses incandescent bulbs instead of what you normally see, which are LEDs. So I'm going to try to...
Oh, that's nice because they have like a warmer glow.
Yeah.
Oh,
Can
yeah.
you- yeah.
Whoa.
That's beautiful.
Yeah, thank you. And that's kind of a side view. And then this is the back side, how it's all wired up.
Oh, that's neat. I like that it's a combination of old tech and new tech.
That's kind of what I was going for. Yeah, wanted something kind of retro looking, but also
Did a really good job
futuristic.
with the wiring. That's very neat.
Yeah, this is like IKEA catalog. It's like perfect.
Yeah, I guess I'm a little OCD about that stuff.
Well, you know, if you weren't going to show someone, maybe you could leave it messy, but it's on the show and tell.
Yeah.
So you can get a chance to show the wiring. It actually does matter.
Yeah, but I just used the ESP8266 Huzzah and automatically grabs time over NTP when it powers up, so
Yeah. So
automatically sets itself and everything.
you have to set it. I guess the only thing is eventually you have to just change the bulbs once in a while, right?
Yeah, I've had this for about a year now, and I have not had one go out yet.
Oh, great. Yeah, we were just talking about all the signs in New York used to be bulbs, but now they're LEDs, and someone had to change those.
I've got it down, so that may be why they're lasting longer.
Yeah.
I kind of like the, it reminds me a little bit of like 1960s ski chalet. You know what I mean? Like I want a fondue set now.
Yeah. No, the wood with the coils is a really nice, really nice look. Well, congratulations,
Classic.
Matthew. We'll send you out a As Seen on the Show and Tell sticker, which goes great on the front or the back, either one.
Appreciate it.
Love
All
it.
right,
Thank
so
you.
much. All right. Next up, Attila. Did I pronounce that right? Attila, how's it going?
Hi,
Hello, Mike, and show us your project.
NASA.
Hi. Yeah, so kind of relevant. Giving a little backstory. I study aerospace engineering here at the University of Windsor. I'm a second-year student, and I'm part of a team. And what we do is we're in a competition where we have to build a rocket and send it 10,000 feet in the air. And what I do for the team is I'm an avionics engineer, and what the normal amateur rocketeer does is they buy third-party off-the-shelf altimeters and other aerodynamic sensors, and they put it on the rocket. And I said, as having a little background in makers and hacking, why not just make my own? So what I have here is a Raspberry Pi Zero with some of the Adafruit sensors, the BNO 055 and the BNE 280. And what I do here is I log that data using Python. I log all the aerodynamic data, gyro, magnetometer, accelerometer, altitude, and then I log it all. And then what I plan to do is put it on the rocket itself. And after launch, I grab the data and I plot it, and then I do other aerodynamic analysis with that, finding apogee. And then what I want to do with that data is put that data into something like Unity, and then eventually simulate the rocket launch in a 3D environment. So that's
cool.
It's not. Yeah. I like to thank the Adafruit Python pages and stuff for the source code and stuff. I actually had to add my own function because I think the Python version of your code didn't have altimeter reading, but your C did, so I had to convert from C to Python. But other than that, it was a really fun project, and we're actually launching next Saturday.
all of our code is in space.
I was
tested
waiting for some rocket scientists to come by and do it for me.
Well, outstanding. Well, email support@adafruit.com, and not only do you get As Seen on the Show and Tell sticker, we have a high altitude balloon badge that I don't get to send out that often. So just put the request in there, and we'll send you out one of those as well.
All right, awesome.
That's
Thank you so
cool.
much.
Congratulations on
Come
your
by with more
project.
projects.
Come back and show more.
Yep, I will do. Thank you.
All right. Next up, Orlando. Orlando, unmute your mic and show us your project.
Hey.
So keeping along my biomedical engineering type things, I built a breakout board. So it's an Arduino shield, specifically for the Arduino 101. I kind of entered a contest on Hackster. So the idea behind this Arduino shield is that it has a lot of biomedical sensors on them. So temperature, heart rate, the whole EKG, muscle sensors, all those kinds of things. So the idea is if someone can get a shield with all those sensors, they can prototype with all these different kinds of biomedical devices or whatnot. So I guess I'll switch to a screencast. Well, I remembered how to do that before I got to this point. Just to show you the circuit layout in Eagle.
I like the couch eagle. This is like chilling.
You guys see the schematic?
Mm-hmm.
Okay, so this guy is the AD5933. It's an impedance analyzer from Analog Devices. And it gets you your whole imaginary part of the impedance and the real part of the impedance. So it's really, really cool chip. And it's pretty inclusive, really. It kind of does all the work for you. This guy here is a current source because for biomedical devices and biomedical impedance measurements, typically, you want to do current source stimulations as opposed to voltage source stimulations, just so you can control the current and not blow people's heart up or anything like that. Instrumentation amplifier, because all impedance things use instrumentation amplifiers because they're a high impedance input and easy way to set the gain and those kinds of things. And then you have like temperature sensors, light sensors, all those kinds of stuff. So yeah, I just wanted to make a cool Arduino shield for my BME buddies to learn about hardware. So.
Right
nice.
On. Okay, well, you get a As Seen on the Show and Tell sticker, and of course, pick your favorite badge that's relevant to the project.
Also, thanks for the badges last week. I
Okay.
forgot to give the kids before you left, but we're going to mail it to them.
Sounds good.
One left over and got them, loved them. So that's really cool. So thanks again.
And thank you so much for helping to make the next generation of scientists, engineers, and biohackers. All right.
Sir,
Okay.
trying to follow.
All right. Well, next up, we're going to go to Roberto and then see Scott.
Adam, did we go to Adam already?
Let's see. You can go to Adam. So we're going to try to get through everybody really fast. So Roberto, a couple minutes, and then we'll go to Adam, and then we'll wrap up with C. Scott. So speed round it.
Okay. I hope you can hear me well.
Yep.
Yeah.
The first thing, first thing is I really enjoy coming to Show and Tell every time I'm here, and all the times that I just get to watch it on as a spectator. And it's really hard, man. So that got some good shows there, sir. So for my Show and Tell,
thank you.
and I've shown before, which is the Jenkins Jobs LED status indicator.
Oh, nice.
Built from really one strip, the 3-meter strip cut into 3. A Jenkins RSS feed replicating the status of the builds, integration tests, and deployment jobs. Got high visibility at the company I work for because performing workshops have something out there, so as you walk by you can tell the status of your product.
Yeah.
In terms of is it up, is it testing, is it building, like something that this is the end product pretty much of what I showed a few times back.
Yeah, no, I remember. This is great. And I like how you use the strip. That's a really smart way because it lights up more. It says the status of what's going on.
Yeah, and my manager suggested using a whiteboard so that instead of having to pull off the tape or Velcro, I use tape, but he said just use a whiteboard and then you can just erase the name of it.
That's smart.
Wow, that defines and map too. The second thing is I mentioned to you, I think in an email field that I was working on control dolls.
Yep.
They're made with OpenSCAD from an original model that had just one head. And so that was the easy part, but that was kind of like, yeah, that's how you do it. And to get the hair going, I used OpenSCAD again. Pretty much what was on Harry Lion, but I just did it on 2 square rectangles. There's a video on YouTube if you want. So that was a fun project. If they want to find them, if folks want to find them. The other thing was when I was working on the LED status indicator, user story at my job. So like I was paid to do that during some of the stuff that we had on like what exactly it was going to do. If he wishes for the days that he works at home, he could show a do not disturb sign to his wife, because he doesn't want her to come in and stuff. And so what I did was put the URL on the back. So anyway, let me just tell you what it does. So this is a feather huzzah. Oh, I think I did it right when I turned it around. There's basically two URLs that the feather huzzah listens to. So on do not disturb, then it shows that. I guess it's not going to find it, but that's the intent of this project, is to
totally
provide a little web server that indicates whether you're online or not.
These are great DevOps projects. Outstanding work, Roberta.
Oh, thank you, sir. Like I've just been working on little things. I haven't been really putting in projects that require a bunch of work. And lastly, and I can try and do this one even more quickly.
Oh, you're cutting out a little bit.
I was just saying, on this TFT, I'm working on getting a swipe left, up, and right down detection. So I just gotta map that over. And what I want to do is put like a contact info. The first picture will be like my email, my that's a work in progress.
Okay,
cool.
come back next time and show it off.
Show more.
Thanks for having me. Have a good night.
Okay.
All right, we're gonna go to Adam, and then we'll wrap up with C. Scott. Hey, Adam, how's it going? I'm your mic, and show us your
Hey
project.
there. Can you guys hear me?
Yeah.
Cool. So I've got straight from 1980 a scanning electron microscope that was surplus from Boeing in 2002. So this thing was a really lucky eBay find. I've been looking for one of these for about 3 years now. Got this thing. This guy had it since 2002. He took it apart into all of its component pieces, which I'll show real quick after I start screen sharing. Let's see here. Once again, I have to remember how to do that. Okay, well, we won't be screen sharing today, but
it's getting microscope then to operate Hangout.
I know, it's really hard.
Yeah, so no, this thing, it's relatively complicated. It has a 40,000 volt power supply. I still have to get working. I still have to get high vacuum systems working. So, I mean, this device will basically be able to image things that are on the scale of basically just above atoms. If you look at, you can look at current semiconductors or something like this. Thus, you see really, really tiny things that you can't see with an optical microscope.
Yeah.
To do that, it has a bunch of really complicated systems. You have to have it under an ultra high vacuum. You have to use 40,000 volts to accelerate the electrons. And then you got to control all of that. So it's a work in progress right now. I'm still missing some components, and most of the components aren't installed in it yet. And the manual is not all in English. This device was made in Japan in 1980. So the schematics and drawings are in Japanese, which makes things interesting. But other than that, I hope to have it online in about 2 weeks and start scanning some stuff with it.
Oh, that'd be so awesome. Come back and give us your
outstanding.
update.
And send any photos and more, and let us know your progress. We'll post it up on the blog, and keep coming back. I have to get
we'll
the scanning microscope sticker.
What a beautiful machine. I love it.
Yeah,
it's a little TFT, not TFT, the CRT and the knobs and everything. That's so cool.
No, so like pieces like this are insane pieces of machining. Let's see here. This thing's got, I think, 18 individual O-rings in it and 3 different thread pitches to actuate one valve. Yeah. There's a lot of really gorgeous pieces of complicated engineering that just make it kind of difficult to put back together again. So all this has to be cleaned, re-greased, and resealed.
Okay.
So, very cool. Thank you so much for sharing that.
Good day.
All right. See, Scott, play us out. You got a speed round it, but you can
guys, I'll be quick here. Just an update on projects. I got disrupted here a couple of weeks ago, but I'm back on things. Here's the GX1 dual filter that I was talking about. It has a filter coupler board. It's all finished. I'll play it next week, but I wanted to get a couple more things built to go along with it when I play it. But I also have, let me switch back to me. Like I said, I've got the front panel to the next one. I don't have the boards yet. Those should be in here in a few days. It's from Osh Park. This is the mixer that I talked about that does the soft clipping. And you've probably heard of the Shruti, a friend of mine named Oliver Gillet. He runs Mutable Instruments. In fact, you sell a version of this called the Data Dealer on your site. And I looked at it at the price you sell it for. This is a really good bargain. So, if anybody's interested in a good entry-level synthesizer, it's not hard to make. It's a good one. However, I'm like, as great as this thing is, it would get, sorry, I gotta swap things around. It would get a little more usefulness if I made a Euromac module for it. So I got the panel done, and I've got the boards in-house here. As falling all over the place. And I've got like here's the front panel board, and I have the filter board back there. It's a work in progress, but more on that when I get it done. Then you probably remember this one's been around for a few years. My big system called CrobiX has 3,000 parts in it. There's nothing plugged in right now, but you put a carrier board on the back and plug 4 voice cards in. I decided it's time for an update. I wanted to. Here's a version 2.1 board. These vertical Molex connectors allow you to drop it straight into a vintage OBX, but I wanted to save using what I called a slot adapter, and I put these right angle connectors on it so I can plug it straight down into a motherboard. My 8-voice motherboard is almost finished. This thing's huge. It's like a pizza box size, and it's 1/8 inch thick. You could throw this and kill somebody. Anyway, I'm moving right along to version 2.3 of the board that fixes a few mistakes, like I don't know if you saw the resistors. And while the show was going on, I was working on the update to the front panel board. Anyway, that's it.
All right, you did it. Woo! All right, that was intense.
Everything.
All right, thank you so much, Roberto, Orlando, C. Scott, Tula, and your Adam, and everyone else, Noam, Pedro, JP,
thank you
and Tony D. Thank you for making this the best half an hour and 2 minutes. We'll see everybody on Ask an Engineer.
We had 12 people on the show.
That was a lot.
That's a record.
All right, thank you so much, and we'll see you on Ask an Engineer in like 45 seconds.
Come back next week, everybody.
Bye-bye.
See you, folks.